Okay, we're back, and it looks like there were some questions. When I do the attach to motion path for the stem to the curve, my stem group goes up. Is that normal? It has to do with the placement of the stem group's pivot, because what's happening is that pivot is actually attached to the location of the end of the curve. And so if there's any distance between the pivot of your group and the actual geometry within the group itself, then you'll see things kind of bump up a little bit. So yeah, that's perfectly natural. Okay, so we've got some rigged up creatures at this point, in this case little wobbly cherries that do all sorts of fun stuff. And our next topic is to take a look at the process of animating this. So let's move over and talk a bit about keyframe animation. Because that is what we're going to be using to create this motion. All right, first off, what is a keyframe? Chris, are you still with us? Are you feeling okay? All right, well, Chris may have actually had to step out for just a moment. So I'll just tell you what a keyframe is. A keyframe is just a recording of an attribute value not over, we'll just say at a given time. Keyframes are recorded inside of Maya by way of a graph, and this graph actually looks something like this. In the vertical axis, we have our attribute value, and across our lower axis, we have time. And simply put, all you're going to do is say, all right, here at the beginning of my timeline, I want my attribute value to be, let's say here. Then, at some point later on in time, say at the very end of our timeline, we want our attribute value to be maybe up here. That's all you do. You just tell the computer, at this time, make sure you're set to this. At this later time, make sure you're set to that. And the computer automatically interpolates between the two times. Practically speaking, this means you could take something like a ball and say, at the beginning of time, I want you to be sitting on a table. At the end of the timeline, I want you to be up in the air. And that's all you do. You give it those two pieces of information, and the computer automatically makes the ball move upward. Now, this process, this interpolation, and that's going to be an important word in keyframe animation. Keyframe animation is animation created, let me write that just a little bit more nicely, via interpolation between keyframes. So again, you only have to give a minimum amount of information, and the computer will do the rest of the work. The way this is done, the way this is handled in the computer, is again by way of these curves. These curves are created automatically. You do not have to create them, though you can edit them. You can change them around. And these go by a lot of names. These are called animation curves. They are called interpolation curves. I've heard them referred to as function curves, and as F-curves for short. And they probably have other names as well, but they all mean the exact same thing. They mean a curve that is used to plot how an attribute is going to go from one value to another value over time. Now these curves are really where your animation is at. They are how you control the nature of your motion. Think of a keyframe, again, as just saying what value something's going to be at a given time. Your interpolation curves, in turn, define how you're going to get there. Now, I'm not sure how many of you are familiar with reading an acceleration curve or a graph of a change over time. So I'm going to try to keep this as straightforward as I can. A flat curve is equal to no animation. Now, how do I prove that? Well, let's assume that this value, so maybe this is 0, this is 1, this is 2. So let's say that this line exists at 2. So here at the beginning of time at frame 1, we have a value of 2. Maybe here we're at a value of 10. What's our value? Well, still 2. And here we are at frame 20. What's our value? Still 2. We haven't moved. We haven't changed. Therefore, a flat line is equal to no animation whatsoever. Okay. So we have the concept that a flat curve is no animation, but then you see a curve like this, and in this case we have this kind of an S-curve shape. So take a look at the shape of this curve. This is telling us something about the animation. What is it telling us? And usually I ask first, but I'm going to give you guys this first one, and then I'll draw some other curves and see if you can help me out. So at the beginning of this transition, from one keyframe to the next, we have a curve that is almost flat. Then you'll notice the slope gets a little steeper, and then steeper still, then steeper still. Then it starts to get flatter and flatter and flatter. And I'll give you another little tip. Slope equals speed. So what this curve is defining is motion that starts off slow, accelerates, and then decelerates. So slow, fast, slow. That's where you get that S-curve shape. Now keeping that in mind, if I erase all this stuff out, what sort of motion would be defined by a curve like this? Somebody over inside of BuzzNet, tell me, what kind of motion would be defined by a curve like this? Speeding up. Very good. We're going to have slow first and then fast. So Kiwi kind of gets the first cookie. Florum gets a piece of that cookie. I kind of liked his explanation a little better. So we have motion that's going to be almost non-existent. Very, very, very slow. And then it's steadily going to get faster and faster and faster and faster. How's it going to stop? Abrupt. There you go. So Florum is right. It's going to stop abruptly. So there's your other cookie. Okay, very good. And clear out some of this extra space. How about a curve that was shaped like this? What kind of motion is defined here? Fast and slow. How is it going to begin? How is the motion going to start? It's going to start fast. That's right. Foe's got it. It's going to be instant motion. That's what I was really looking for. We're not going to see any acceleration whatsoever. We're going to go from 0 to 60 miles an hour over the course of 0 time. We're just going to immediately be moving forward. So it's very, very jarring. Excellent. All right. How about this one? What kind of motion is defined here? Linear. Linear doesn't really... That's right, but it's not the what I'm looking for. Florum actually got what I was looking for, which is the word constant. We're going to have a constant rate of motion that never changes. We neither get faster nor slower. We're not going to see any acceleration or deceleration. We're going to immediately begin moving at a constant rate and then stop at that rate. So it'll look kind of like you slam up against a wall. Okay, perfect. I think with all of that down, we're ready to go ahead and begin the animation process. So let's jump over to Maya. All right. Now, I want to give a quick demonstration of animation before we go any further. So I'm going to save my file right here and just go to File, New Scene. And here's my grid. Now, to show you guys a little bit of what I was talking about early on with how keyframes work inside the computer, I'm going to create an object. Let's just make, well, I don't know, let's do a polygon sphere. And I'll just drag it right here at the center of the grid, or at least somewhere nearby the center of the grid. Now, what we want to do is create a keyframe. Again, that's all you do as a keyframe animator. You just create keyframes, and then you edit those resulting curves to get the type of motion you're looking for. Ooh, real quick divergence. I'm just curious. And Faux, back off. I know you know the answer to this one. Sit on your hands for a minute. Who can tell me what kind of motion that is, or what kind of animation that is? Describe it to me. Warping, binary, Paul got it, instant. He said it first. Teleportation is another pretty good one. So constant, then instant. Very good. And actually, really, to do this, we would need a keyframe up here. So that's more like what it would look like in Maya. But I just wanted you to understand what the curve did. We'd have unchanging values. So everything would be the same. And then immediately, we would jump up to this value and continue on. Can anybody give me one example of where you might want to use something like this? And don't say motion. You don't want anything to ever move like this. Not really. There you go. On and off. A TV being switched on and off. Or a light. Or anything that is going to need to suddenly flick on and flick off. So that's what you're looking for. Okay, I just wanted to kind of throw that out there real quick. So let's talk about creating keyframes. There is the slow, well, not slow, it's actually very fast. There's the sloppy, nasty way to drop keyframes. And then there is the elegant way to drop keyframes. I'm going to show you both of them. So here I am at the beginning of the timeline, and I'm going to press the S key. And what the S key does is it keyframes all of the attributes currently in the transform node for the attribute editor. So notice we've keyed translate, rotate, scale, and visibility. Next, this is part of a process I want you guys to be paying attention to. So at the beginning of the timeline, I pressed S. I'm now going to move the timeline to the end. It's important that you do that first. I'm going to take my ball and just move it straight up into the air. And press S again. Notice here in my timeline, I have these two thin red lines. These denote keyframes. This is how I know I've recorded data at those times. Now I drag my time slider, and I have motion. Now the reason S is generally sloppy, in my opinion, is that take a look at what we've actually animated here. What is changing over time, really? Just translate Y. We could have got this entire animation, this exact same thing, just by keyframing translate Y, and yet we keyframed all of this other stuff as well. That means that we have excess keyframes, which is just data that Maya is going to have to process for no reason whatsoever. So try not to hit the S key. Now, later on, once you have started animating and you start animating more complex characters, you're going to learn about something called character sets. Character sets are very neat because they allow you to use the S key again and to define what the S key actually means. So those are very cool. But we're not going that far right now. So generally speaking, we're not going to use the S key right away right now. What I am going to do for now is rewind all the way back to the beginning, and I'm going to nuke out all of my animation. I'm going to do that by selecting all of these attributes. So click at the top, drag down to the bottom, Right-click and choose Delete Selected. By the way, you don't really have to be following along for this part, so if I feel like I'm going a little quick, that's okay. You're going to be seeing all of this on the cherry here in just a moment. Okay, now I'm going to animate this again just by animating the attributes we need to see, and I'm going to bring in the use of Auto Key. Auto Key is a nice way to speed up the animation process for us. I'm going to right-click on Translate Y and choose Key Selected. Actually, yes, you can remove extra keys, just in case you know that. We're not going to be going into that. I'd rather you animate cleanly from the get-go. We will have a few extra keys in terms of translate and rotate values that we won't be using right away, but I'm leaving them there in case you guys want to use them to make your animations look a little cooler. So anyway, I've keyframed Translate Y. Now I'm going to turn on Auto Key. It's this little tiny key icon in the lower right-hand corner of the screen. Just click that so that the button turns red. Now all you need to do is move the timeline and move your object, and as soon as Maya detects that a keyframed attribute has changed, it will automatically place the second keyframe. You do have to have the first keyframe in place, however. Now, with just that in place, just this ball going up into the air, I want you to go under Panels, jump down to Saved Layouts, and choose Persp Graph. What this does is it gives you a perspective view and the graph editor, and here's that graph that I was drawing out over inside of Photoshop. We have attribute value on the left-hand side, we have time running across the bottom of the graph, and we have that curve that Maya automatically generated in between our two keyframes. Everything I was showing you. In fact, if I hit play, you can just make out that the ball is accelerating and then decelerating at the end. You might, however, see something like this. When you hit play, you might see something really, really fast. It's impossible to tell. That's because by default, your playback speed is probably set to free, which is playing every single frame as fast as it possibly can, and the faster your computer, the faster that's going to be processing. So, if you hold down the right mouse button on the timeline, set your playback speed to real time, and that'll solve that problem. Okay, so there's our quick demo of animation. Now let's go ahead and get our scenes animated. So I'll go to File, Recent Files, and this should be my cake project that I just got done with. We don't need to save this file. And we are prepared to go ahead and animate. But let's go ahead and do some things. First off, set your total number of frames to 100 if you haven't already. We're only going to be using the first 90. I'm giving you the next 10 or however many you want. If you want to add a whole lot more, then you can add as many as you like. But those last 10 are there in case you want to add a little bit of additional wobble to your animation. All right. So we're pretty much ready to go. I want you to go to Panels, Save Layouts, and choose Persp Graph. All right. So we can see our graph editor, we can see our perspective view. Now, please understand, while we animate, we're only interested in these locators. So if I were you, I'd do a few things. Go to Show, make sure that locators are still on, but there's some things we don't really need to see. We don't need to see NURBS curves, for instance, so go ahead and hide those. We do not need to see deformers, so turn those off as well. Finally, I would come up here to my status line and switch off geometry, so just leave that off. Now I can't accidentally select the cherry geometry. Now, we're going to be building up our animation in layers, one process at a time. At first, we're just going to animate the ball, thank you. We're just going to animate the cherry going from its starting position to the top of the cake. And that's it. It's just going to fly straight to that point. Then we're gradually going to build up on that animation and turn it into a bounce sequence. So let's get started. Begin at frame 1. And I want you to key all 3 of your translate values. You can do this very easily by hitting Shift W. Remember W for the move tool? If you hold down Shift and hit W, that keyframes all of your translates, which is a very nice trick. Next, slide your time slider all the way to frame 90. And in your scene, get your move tool out and just position your cherry right on top of the cake where you want it to be at the end of the animation. So I'm going to put mine a little sunk down into my whipped cream. Down here in the graph editor, if I tap the F key to frame up, I can see all of my curves. I'm moving in 2 axes right now. I'm moving up and down in Y, so actually I'm just moving up in the Y axis, and I'm moving forward in the Z axis. Let's do a quick ready check for people to get to this point. Okay, so we've got our initial motion. We're going to do a couple of things, though. First off, we have a bit of a problem with our forward momentum in that I don't want our cherry to be speeding up and slowing back down. And we can see that with the S-curve. In fact, just click on Translate Z, and you'll see it's got this S-curve shape. Tap the F key if you need to show that very nicely. So it starts off very slow. It gets faster, and then it slows back down. We want this to be a linear relationship. To do this, select the curve, so both keyframes are selected, and then click on the Linear Tangents button. It's located right about center line on your toolbar. It's just a little tiny diagonal line coming out of a keyframe. Now this means we are moving forward at a constant rate. That will help your animation look much nicer as we move forward. Now, we're going to set up our jump, and for now, all I'm going to do is click on Translate Y and only show that. Each jump that we're going to create is going to be 30 frames for a grand total of 90 frames. What I want you to do is move forward to frame 30. Take Translate Y and set it back down to 0 for now. Not frame 31 either. Let me tap undo. So right here at frame 30, I'm setting Translate Y back to 0. Now, that's just going to mean your cherry is sliding across the table instead of jumping. But that's okay. Don't worry about that yet. Next, move to frame 60 and do the same thing. Set Translate Y back to 0. So, we're sliding, sliding, and then we rise up and we sit on top of the cake. All right. Now, you can think of these keyframes here at 30 and 60 and 90, even the one at 1 here, as anchor points. They're going to keep the cherry grounded each time it bounces. So now we're going to add the bouncing mechanism. So let's come out to frame 15, and I'm just going to lift the cherry straight up into the air to the height I want that first bounce to be. And as I scrub the time slider, you see we go up, we come back down, because we set those anchors. Next, we'll go to frame 45, and I'll lift up a little bit higher. You can use your graph to see how high up would be higher. If the curve goes up higher, so does your cherry. Finally, I'll go to frame 75, and I'll go really high this time. So we're going higher with each bounce. Let's go ahead and do another ready check at this point. Okay, we've got some up and down motion, but it's the wrong kind of up and down motion. The problem we have right now is that we have this sort of wave style motion. Take a look at our translate Y. If I hit F to really show that off. Again, notice this S-shaped curve segment. It means we're speeding up and then slowing back down at the top. That's fine when we go up into the air, but we want this to look like he's falling down and striking a table. And as objects come, as they fall, they tend not to slow down before they hit the ground. As a matter of fact, they're often still accelerating. So to make this look more realistic, we're going to stop that deceleration on our way down. Here's how we're going to do that. I want you to select all 4 of the keyframes, and I'm holding the Shift key to select those. Grab all 4 of the keyframes where the cherry is planted. Once those are selected, click on the Break Tangents button. What Break Tangents does is allows us to take these tangent handles, which are pointing out of each keyframe, and to bend them in different directions. See, if we don't do that and we try to adjust these tangent handles, watch what happens. They stay in a straight line, and that won't work for us. So, again, we're going to grab all 4 of those keyframes and then click on Break Tangents. You can free the weights too if you want to. I would not. You don't really need it. If you were to do that, by freeing the tangent weights, you can take a tangent and you can start to stretch it out and give it more Bezier weighting. We do not need that to get a nice realistic jump in this case. But as a random tip, we're not going to explore, but I mean, if you wanted to, you could. You could free your tangent weights and then get rid of these keyframes at the top of the bounce and just use weighting to make your ball go up and down. Just, random. Okay, so once you've got those broken, now all we need to do is adjust the tangent weights, and there's a little bit of a process to this. Select the keyframe, then select the tangent handle, then use middle mouse to change its angle. Once again, select the keyframe, select the tangent handle, use middle mouse to change its angle. And see, the nice thing about doing this is that we can now take those handles and bend them in 2 different directions like so, and you see we get that nice bounce style trajectory where we're accelerating into the ground, boom, and then we're accelerating away from it. And even if we scrub through, this first bounce now looks far more natural. Alright, so we'll grab the next keyframe, pull this handle up a little bit, pull this handle up a little bit, and really all I'm looking for is a nice shaped arc along the top. We just take this last one, grab that one handle, and pull it up a ways. And there we go. Boing, boing, plop. And if we play it, all right, so while everybody kind of gets caught up to that, I'm going to do a kind of a rolling ready check. I'm not actually going to pause the video. I want to bring up a very important concept that I think beginner animators get all caught up in. I'm going to write it big so it takes up the whole screen. Motion is animation. If you want a character or an object to move around your scene throughout the process of a video, that is animation. That object has to be animated. But not all animation is motion. So I don't want you to, in your head, think that animation is always about moving an object, because you can animate all kinds of things. You can animate colors. You can animate whether a light is on or off. You can animate the value of a property, which makes something else happen or changes the value on a shader somewhere. There are all kinds of things that you can animate that have nothing to do with moving an object across the screen. So even though this project centers primarily just around us animating by way of moving an object around, I don't want you to get that locked in your head that that's all that animation is about. All right, back over here to Maya. Let's go ahead and give everybody just a moment to get caught up, and then we'll continue. Okay, so we've got our actual motion in place, and now it's time for us to add our secondary animation for the squash and stretch. Once again, I'm going to make you guys handle the animation of wobbling the stem up and down. So, Paul, is this going to take much more? Do you need to go, man? Actually, true story, we're almost done, believe it or not. We don't really have too much more to go at all. So, what I want you to do is begin by animating squash and stretch, and we're going to go all the way back to frame 1. Select the squash stretch attribute, hold down the right mouse button, and choose key selected. So you got to get that first keyframe in place. Now this is very easy to do. Just go a few frames forward. So I'm going to go maybe 3 frames up and stretch the cherry out. It doesn't have to be by very far. I mean, don't get all crazy with it. The subtler you keep it, the easier it's going to be to believe what's going on here. So I'm going to pull mine up to about 0.4. Now, just a couple of frames before we hit the ground, so here I'm at frame 27, I'm going to set squash stretch back to 0. Now what does that mean? That means he's extended himself to jump up into the air, but then as he flies through the air, he's going back to his original shape. Right here at frame 30, though, I'm going to squash him down. So we'll do negative 0.3. So one more time. At frame 3, he's stretched up. All the way up to frame 27, he goes back to 0, his original shape. And then at 30, when he's on the table, he's squashed back down again. If we click on squash stretch and tap F, there's what it looks like. Now, I want you to go just a couple of frames forward from 30, so maybe 32 would be good, and stretch him back out. So this time we'll go to 0.5. So again, at 3 he's stretched. At 27 he's back to his original shape. At 30 he's squashed. At 32 he's stretched again. Now we're going to go to right before he lands. Say we'll go to 57 and we'll set him back to 0. What that means is, again, as he flies through the air, he's going back to his original shape. At 60 he's on the ground. Let's squash him down. Go forward 2 more frames, and this time let's give him a really good stretch. So we'll push him all the way up to 0.6. Now, all I'm going to do from here is just say all the way to frame 90 when he lands. Actually, we'll go just a couple of shy of 90, just as we did before. And we'll pull him down to 0, so he's back to his original shape. At 90. Now, you can stop it right here. You could just leave him, plop, and he's fine. But if you want a little more life in him, maybe go to 91. You could set it at 90, but here at 91, I'm going to squash him just a little bit, like 0.1. At 93, I'll stretch him just a tiny little bit. And then at 94, we'll set him back to 0. And all that does is that just puts a little wobble right as he lands. And there's the animation playing over and over and over. And here is the entire animation curve. Looks like little shark fins or something. If your animation is going too fast, make sure you hold down the right mouse button, go to your playback speed, and make sure you're set to real time. You could be set to play every frame or free, and if you're doing that, you'll get something like this. It's funny, Wick, that you should say that, because a lot of people don't like, although some folks, not a lot, some folks don't like how it kind of anticipates the bounce. I always thought it made it look like he was jumping. So it's like he's less of a passive character now that's kind of like wobbling like rubber, and more like something that is literally like, even though he doesn't have them, kind of sucking his feet up and getting ready to jump, and as soon as he hits the ground, he stretches himself back out and goes into a nice little leap. That's how it always felt to me, anyway. Okay, so let's do a quick ready check. All right, we're now ready to move on to the final part of our animation, which is just adding in some rotation to the bounce. This is a very, very easy process, and it's going to follow kind of our squash and stretch. So here's what I want you to do. Rewind all the way back to frame 1 and press Shift-E. Remember that E opens up the rotate tool. Well, Shift-E puts a keyframe on your rotation values. At frame 3, so that same key, or that same location, that same frame where we stretched him out, get your rotate tool out and just rotate the cherry forward a little bit. Now, come all the way back to right when he's back to his original shape at 27, and then just rotate him back a little bit. Doesn't have to be much. Forward, and then back. And see, it's like he's kind of sticking his feet out like he's ready to land. Then, again, go to the keyframe where we stretched him up again. Rotate him forward. Right before he landed, rotate him back. Right as he lifts off, whoop, careful there, rotate him forward. So I'm really just animating X, but if you want to add additional rotations to it, just kind of for fun, you can do that. Now, for the last one, I would just rotate him back a little ways and sort of leave him there. And that's it. He is moving. There's actually a part of the rig that I overlooked. This time around, I did it in the Tuesday class and I forgot to do it here. And here's how I remembered it just now. As our little guy here is moving, notice, actually as he's rotating, let me be more precise. I'm going to turn off auto key so I don't accidentally break something. So I'm going to kill auto key and show you something. As we rotate the cherry, notice the stem. Can you tell me what it's doing? It looks kind of weird, but can you describe it to me? No takers. It is not rotating. Its position is updating, but but its rotation is not. So here's how we're going to fix that. We are going to create an orientation constraint, or an orient constraint, to cause our stem group to rotate along with our control. So a constraint is just a way to feed data from one object to another. The reason you use a constraint instead of the connection editor is that you can make constraints do other things. You can create offsets with them, you can animate the value of a constraint, and all sorts of other fun stuff. Also, they help you get over problems where if you have two objects built in two different axes, but that's a little outside of our scope. But what I want you to do is, first, select your control. So grab your great big locator that's controlling this. Then you need to select your group. And to me, the way we're going to do it is I'm going to go into my hierarchy view, and I can select my group right there. So there's group cherry stem, like so. So select your control object, then select your group. Notice the selection order is kind of backwards to parenting. When you're parenting, you always select the child first, and then you select the parent. We want the stem to follow the locator, so you could think of it that way. It would be like the stem is the child, the big locator is going to be the parent. But we're selecting them in reverse order. We're selecting what we want to follow, or the object we want to follow first, and then the follower second. So it's constrainor and then constrainee. Next, press F2 to go to your animation menu set. And after you're in the animation menu set, go to Constrain and choose Orient. Now, when you rotate the control, you see the cherry stem just comes right along for the ride. So all we're really saying is that as the control rotates, so too does this group. So once again, that was select the control, then select the group, then go to Constrain and choose Orient. And that solves our little rotation problem with the stem. It doesn't change anything about our animation. The animation now works just fine. Now, that's it. That's everything that I was going to cover today. Your task for your homework is going to be to create this animation that we've created here. Then you will also animate your stem wobbling up and down. Don't overdo it. A little goes a long way. I mean, you notice you can stretch your cherry stem out, make it look like a frog tongue, and do all kinds of fun stuff with it. Keep it very simple, and things will look far more realistic. Now, if you just want to follow exactly the bounces so that maybe when you're up in the air, it's up, when you're down on the ground squashed, it's down, that will look okay. And I'm not going to nail you on that. That's fine. Really, I just want to know that you can animate this. You don't have to make the animation look elegant until you've had some practice animating. But if you want things to look really, really nice, consider that the motion of the stem wobbling up and down will actually take place slightly after the motion of the cherry. So, the cherry will start to lift up into the air, and because the cherry begins to go up, the stem will get pulled down. Then, the cherry will start to fall, and because it's starting to fall, then the cherry will go, or the stem will go back up. Then we hit the ground. That motion is not going to be instantaneous for the cherry, for the stem. The stem won't immediately hit the ground here, or it won't bend down. Everything will be fine until it starts to kind of go up on the next frame, and then the cherry stem is going to bend down, kind of like a shock. Yeah, it's behaving kind of like a hair or like a little aerial antenna. It's just kind of wobbling. That's if you want it to look really good. Put a tiny little 1 to 2 frame delay on it. Really, you can just make it bounce up and down. You can give it a motion that's almost exactly identical to the type of motion you see on the cherry. Almost. But if you delay it by just a couple of frames, it will look far more realistic because it'll look like it's trailing behind the motion of the cherry, which is how it would behave in the real world. Okay, so that's everything, folks. So if there are no other questions, that is actually going to wrap up today's class. I want to thank everyone for attending. It's been absolutely amazing, and I wish you all the best of luck with this assignment. To me, this is where stuff starts to really get fun, because you get to take your little creation, which up to a moment ago was just a boring little cherry, and we've now made it something very interesting, with the cherry now kind of coming to life and really leaping across the screen. So, thank you all very much, and I will catch you all next week. Take it easy.